deals with the exponential decay model. And as you can see, there are a lot of similarities between the exponential decay model and the exponential growth model. Really, the biggest difference is right in here. You're still going to have your initial amount. T is still going to be the time period. But instead of increasing by the same percent each unit at a time, it's actually going to decrease each unit at a time there. And so we're going to have that rate of change there. The R is going to be that rate of change, and that's going to create our decay factor. One thing now as we look at it, R here for the decay factor does have to be between 0 and 1. It should make sense to you. If it's 0 exactly, that means it's not going anywhere. It's just going to stay the same. So that one wouldn't be decaying. It'd just be staying the same. And if it was more than 1, it would be negative, and that doesn't really work with it either. So this decay factor here is going to be between 0 and 1 to be an exponential decay model. A good example of this is with things depreciating. And so right when you drive a car off the lot, or right when you buy a computer or do different things, it immediately starts to depreciate in value and work its way down. So we're going to do just a couple of depreciation values, and then in another video I will graph two different exponential decay models. And so as we look through this first one here, we have a used car. And so we go out and we buy a used car. Some of you are going to be getting ready to do that here in a year or two. We go out to get that used car, and we buy a used car for $2,300 there. Now, with that used car, it is depreciating at a rate of about 8% per year. And so we want to know in 2 years, if we want to buy another car, maybe before we go to college or something like that, we want to know kind of how much that's going to be worth. And so we go ahead and we go right into our model here again, just like we did last time. We want to make sure we have that model, 1 minus r to the power of t. And as we look, we start putting in what we know. I know that that initial amount is $2,300. Now I know that the rate of change is 8%. Remember, we always want to write that as a decimal. And I'm taking that, in this case t, I'm looking at t being 2. So I need to go through and do the math on that. I do my parentheses first. 1 minus 0.08 is 0.92. And I'm squaring that. When you square 0.92, you get 0.8464. When I take that times 2,300, I get $1,946.72. And so if you're careful and you don't get in accidents and all sorts of stuff like that, if you take care of the car, in theory, we should still be able to get a pretty good price for it when we sell it in a few years of $1,946.72. Now let's look at another one, same type of thing, $1,800. This one, boats apparently are depreciating a little faster here, or at least in this problem they are. And so as we look at that, again, it really just comes down to plug it into your model. And so know that model, plug it into the model. Our initial price is $1,800. It's going down. 29% is 0.29. And we're looking at it again for 2 years. And so as I look at it, remember to do the parentheses first. That comes out to be 0.71. Then square it. Stay away from doing the 1800 here. That's going to be multiplication. I got to get my exponents out of the way first. And so I have 5041 here, 0.5041. And when I multiply that times 1800, I get $907.38. Remember, we'll always take money, any type of problem that's dealing with money, we'll take it to the hundredth spot. And so, as you look at our exponential decay model, again, you'll notice it looks incredibly similar to what we've had before. Just remember that our R is going to be less than 1 and greater than 0. So it's going to be somewhere between 0 and 1 when you put it in decimal form. Now we're going to do some graphing of these exponential decay problems. And as you remember with graphing here, we're just going to use the table of values method. And for our x is just like the t here. And then we're going to have our y as well. And what I'm going to do is I'm going to plug in some numbers. I like to plug in 0 always because it's usually easy to work with. Whenever I take something to the power of 0, that equals 1. 1 times 2,300 is 2,300. Now, 1's going to be an easy one to work with. Remember, I already worked this equation out here with plugging in 2. And so when I plugged in 2 on a previous video there, I got $1,946.72. And so I've already got that one. Now the 1, I can plug that in as well. When you plug in a 1 there, you get 0.92 to the first power. That's 0.92. When When you take 0.92 times 2300, you get approximately 2,116. And so as I look at that, I want to make sure that I go by nice increments here so that I can easily get there. I'm going to go by 250, and so this will be 500, 1,000, 1,500, 2,000, and 2,500 here. And so as I do that, now 2,300 is going to be slightly above this. That's going to be right here. The 2,116 is going to be right in this area. So I'm working my way down. And then 1946 is going to be right here. And so you can see as it's working its way down there that it's not going super quick. What you have to know about these graphs here is it's just like exponential growth. It's going to work its way down here. And as it comes down through here, it's going to get closer and closer, and this would probably be more like this, but it's going to get closer and closer to the x-axis without actually going past the x-axis. So let me doctor this up just a little bit here. And so we're going to get that kind of look there. Now this side is going to keep working up there. It's kind of just the opposite. It's going to go up as we go this way, and as we come down through here, this is going to work its way towards the x-axis. Let's take a glance at the next problem here, because I think we'll get a little better look at what these graphs are going to look like here. The appreciation is a little bit steeper here, and so I think we're gonna like this one a little better. Again, remember your t is your, just like your x there, and then you have your y. When I plug in 0, I get 1 there, and so I have 0, 1,800. When I plug in my 1, I get 1,278 when I go through and calculate that. And I plugged in 2 during the problem there and got $907 approximately. So I want to go ahead and make a graph of that. I'm going to go by 500s this time just to kind of see how that works there. And so this is 500, so this is 1,000, 2,000, 3,000. At 0, it's at 1,800. So it's up in this area here. At 1, it's at 1,278, so not quite. Remember, I'm going by 500s there, and so as I go there, this is going to be right in this area. And when 2 is at 907, so it's a little below here, right in this area. And so you can get a little better idea of how it's working its way down, it's working its way down, it's working its way down. It's never going to quite get to the x-axis. It's going to keep working its way down, but never quite get there. And on this side, it's going to do the opposite. It's going to be working its way up, working its way up, working its way up. Remember, it'll never quite get vertical as it goes upward. As it comes down, it'll never quite get to 0. And so technically, as it goes down 29% each time, it's never going to quite get to the x-axis there. It's going to keep getting closer and closer and closer, but never quite get there. So those are exponential decay graphs. It is just the opposite of your exponential growth graphs that you had there. So remember, exponential growth will work its way up. The backside tail off to the left will not quite ever get to the x-axis. For exponential decay problems, that will come downhill as we work lower and lower, and that'll never quite get to the x-axis as it works to the right. Okay, as Valentine's approaches, I want to make sure that we have some discussion on Valentine's Day and gifts to get, things like that. Make sure you think about, while a dozen roses are nice, a nice bouquet of roses are good for Valentine's Day, think about a bouquet of bacon maybe as a possible gift idea to your Valentine's. I think they would like that much more than flowers, which wilt and die. A nice, savory, sizzling bouquet of bacon is a good idea there. I'll tell you, I messed up, students, one time. My wife asked for some flowers for Valentine's Day, and I didn't think anything of it. I thought any kind of flowers would work, and I got her cauliflowers, and apparently that was not a good idea. She was not pleased. Hey, what do you call a small Valentine? Valentine. We'll talk to you later, kids. Have a good night.